Hello there. Here we are to solve past papers of grade 12 mathematics examination on complex number. The first question here, it says which of the following is the conjugate of what we see here. There is a complex number which is stated here. So first of all, we need to simplify. After simplification, we'll think of about the conjugate. Okay, so what's given here? First, the modulus of 3 plus 4i minus 25i the whole over 3 plus 4i. This is original question. So let us do step by step. The first part here, the modulus means, the absolute value or the magnitude. So what to do? Just square the real and the imaginary, then put in the square root. This is going to be 25. From the square root will be 5. We are done the first part, the first component before the minus. And then when you go to the second part, let's focus here. We need to rationalize. The denominator is 3 plus 4i, so we need to multiply by the conjugate, 3 minus 4i. When you do that, 25i times 3 will be 75i. Again, 25i times negative 4i will be negative 100i square. But i square means, it is negative 1, so it's going to be just 100 only left. Okay, 25i times negative 4i means negative 100i square, but the I square is negative, that's why. So the whole over, when you multiply the denominator part, the product of a complex number and its conjugate will be the sum of the square of each. So it's going to be 25. You can check 3 square plus 4 square. Now we can take out common as 25 for the numerator part. So if you take out 25 as a common, what left? 3i plus 4 will be left. Then the whole over 25 still will be there. Then you can cut the 25. Then what remains? 3i plus 4 remains. Therefore now, before the minus and after the minus already simplified, so we can now combine 5 minus what? 3i plus 4. When you distribute the minus, it will be 5 minus 3i minus 4. The plus 4 will be changed to minus. Therefore, the reals are 5 and negative 4, so 5 minus 4 will be 1 minus 3i. We don't have to end up here. But unfortunately, there is 1 minus 3i. But we are asked the conjugate of this. When you conjugate, that means we are going to negate the imaginary part. So it will be 1 plus 3i. So the answer obviously will be B. Very good. Let's go to the next question. The second question again. Here are two complex numbers as you see. The first one, z1 equal to 2 minus i over 1 plus i, and z2 equal to 1 plus i over 1 minus i. Then we are asked to find d1 plus 2z2. z1 plus 2z2. We need to find this, which is z1 means 2 minus i over 1 plus i. Then plus 2 times z2 means we will multiply by 2 the second part, so it will be 2 plus 2i. The 2 multiply the numerator part only, and the denominator as it is 1 minus i, because as you see the z2 here, it says 1 plus i, so we made it 2 plus 2i because the 2 multiply each of them. Then to add these two complex number, we can apply crisscross process. 2 minus i times 1 minus i plus again 2 plus 2i times 1 plus i, the whole over, okay, the product of the two denominator. As you see, the denominator part, the two are, one is the conjugate of the other, so it's simply 1 square plus 1 square, which will be just 2. Nothing will be left in the numerator part. So this is going to be, when you multiply this one, the first bracket, the 2 bracket here, it will be 2 minus 2i minus i just minus 1 will be left, the first bracket, like the first 2 brackets. When you multiply, it will be expanded in this form, plus the second one here, the 2 will be common, as you can take out, then 1 plus i left here, and 1 plus i times 1 plus i will be 1 plus 2i minus 1. Hopefully you know what to do here, how to multiply. It's like expansion, so you can expand and you can get this result. So this is going to be the first bracket, 2 minus 1 will be 1 minus 3i, then minus the second bracket, this negative 1 and 1 left, so 2 times 2i will be just 4i will be remain, the whole over 2. This is plus. Okay, 1 minus 1 will be cancelled, and 2 times 2i will be 4i left. So this is going to be 1 minus 3i plus 4i the whole over 2, means it is the same as 1 plus I the whole over 2. So the answer will be found at B. Okay, let's continue to the next question. Again here, what does it say? Z equals negative 3 plus 4i. This is the first complex number, and the other complex number w equals 1 plus 2i. Then what's the value of 2z over w plus the conjugate of w? So first we have to multiply 2 times z. 2 times z means it will be negative 6 plus 8i. The whole over the w is 1 plus 2i plus the modulus, the conjugate of w is 1 minus 2i. This means over 1. Then crisscross. When you make crisscross, it will be negative 6 plus 8i plus 1 minus 2i will be multiplied with 1 plus 2i. The whole over the product of the denominator will be just 1 plus 2i. Now this is the same as negative 6 plus 8i plus the product of these two is the same as the product of two complex number. One is the conjugate of the other, so simply the square of the sum of each. So that means 1 square plus 2 square, which will be 1 square, 1 plus 4, which is 5. The whole over 1 plus 2i. This is the same as negative 6 plus 5 will be negative 1 plus 8i. The whole over 1 plus 2i. Again, we need to rationalize 1 minus 2i over 1 minus 2i. When we expand this one, it's going to be negative 1 plus 2i plus 8i plus 16, the whole over 5 when you multiply the denominator part. So this is going to be again negative 1 plus 16 will be 15 plus 10i, the whole over 5, which is this denominator 5 will be given for each. So 15 over 5 plus 10 over 5 I, which will be 3 plus 2i will be the answer, which is found at C. Very good. Let's continue to the next question. The next question again, it says 1 minus I over 1 plus I the whole the power of 18. We can write this one 1 minus I over 1 plus I the whole the power of 18 can be written as 1 minus I square over 1 plus I square, because this exponent will be given for each, then the whole the power of 9, then the whole the power of 9. We can write it in this form because the exponent can be given for each, for the numerator and for the denominator part, because remember this one, a the power of m over a the power of b the power of m. If we have, we can write it a over b the whole the power of m, that's the reverse process. So the 18 is given for each, the numerator and the denominator part. Again, 18 is the same as 2 times 9, so we need to square each of them. The square of 1 minus I will be 1 minus 2i minus 1, the whole the power of 9 is still there. The denominator part also 1 plus 2i minus 1, the whole the power of 9. This is going to be 1 minus 1 will be cancelled, so negative 2i over 2i the whole the power of 9. We can take the exponent for each as a common, and then cancel I by I, and negative 2 over 2 will be negative 1. The power of 9 is the same as negative 1, because negative 1 the power of odd number always. Negative 1 the power of odd will be negative 1, and negative 1 the power of even will be just 1. So the answer will be negative 1, which is found at A. Okay, the next question, we are asked to find the polar form, polar representation. There are two complex numbers here, the first and the second. So each of them we need to find the r and the theta. The first part, the r is 2 and the theta is radical 3 over 1 will be 60 degree. And for the second part, the r will be radical 2 and the theta will be 45 degree, because the theta will be found by tan inverse of, okay, first part root 3 over 1, tan inverse of radical 3, tan inverse of radical 3 will be 60 degree, and for the second part tan inverse of 1 will be, because 1 over 1 we have to make it. It says tan inverse of y over x. We need to recall this formula. The y means the imaginary part, which is radical 3, and the x is the 1. So radical 3 over 1 means just root 3. Tan inverse of root 3 is 60 degree. The second part it's 1 over 1. Tan inverse of 1 will be 45 degree. We do have two angles. Therefore, the product will be the first complex number is 2, then cosine of 60 plus I sine 60, just this one, times the second part will be radical 2, then cosine of 45 plus I sine 45. Therefore, when you multiply, we will multiply the modulus part, that means the r, 2 root 2. Then we will add the angle. Cosine of 60 plus 45 will be 105 plus I sine 105. That's going to be the answer, which is found at B. Okay, let's go to the next question. The next question, we are asked to find the multiplicative inverse. If this complex number is z, already given to you, we need to find the multiplicative inverse. So that means the inverse is equal to, we need to flip it. It will be 4 minus 5i, the whole over 3 plus 4i. Then we'll rationalize. When we rationalize, we'll multiply by 3 minus 4i over 3 minus 4i, which will be, when you distribute, it will be 12 minus 16i minus 15i, then minus 20. The whole over, the denominator part is 25, which is 12 minus 20 will be negative 8, and this will be negative 31 over 25, which can be written as, there is I here, we don't have to forget, negative 8 over 25 minus 31 over 25i. So the answer is found at C. Very good. The last question for today. The last question here for today, it says W is equal to 3 plus 4i, and then if z square plus 1 over z plus I equal to the modulus of W times z minus 1 over I times the conjugate of W, it says. Okay, so that first of all, d square plus 1 over z plus I, we can write this one as z square minus I square over z plus I form, because I square means negative, so negative negative will be plus, as you see. So we can write this one systematically in this way. The reason, because we know that a square minus b square means it is the same as a minus b times a plus b form. So we can factorize and write this one as z minus I times z plus I, the whole over z plus I form. Then we can cancel this, so what left? Z minus I left, the left part. So z minus I left to the left side is equal to, and don't forget the modulus of W is equal to, when you find the modulus of this one, square each, then in the square root, that means 3 square plus 4 square, which will be 5. So the modulus of W times Z means 5Z only, minus again negative 1 over I times W conjugate, means first of all we can rationalize this by, we can multiply by negative I times negative I. Negative I times negative 1 will be just 1, and it's going to be, it will be I over negative. So the negative is together with it, so we can ignore this negative, simply consider there is no negative here. There is no negative here, consider, because we will bring it later. So negative I times 1 is negative I, and down negative I times I will be just 1. So negative I left, that means it will be plus I times, what is the modulus of W will be 3 minus 4i. So after this it will be very simple. What did I do? First of all, I try to simplify this part. How? Like expanded here, some kind of technique is applied here, we need to take care there. And then the modulus of W is, you know, we know how to find, and then 1 over I means we rationalize, we multiply by negative I over negative I, so negative I times 1 will be negative I, and negative I times negative I just will be just 1, so we can ignore the denominator part, this one just 1, but here negative I, so negative negative will be plus I. Therefore z minus I is equal to 5z plus 3I, this the I is multiplying, plus 4. Then we can reshuffle, we can collect everything here, so minus I, minus 3I, minus 4, I brought everything there, is equal to 5z minus z. I shift the z to the right side. The difference here will be 4z, so 4z is equal to, here 5z minus z will be 4z, and the other part here negative 4 minus 4i, negative 4 minus 4i left. So if you divide by 4 each, so the z value will be negative 1 minus I. So the answer is found at D. These are some of selected problems from the past paper of grade 12 national exam on complex number. I'll continue solving. This will be number 1 video on complex number, and other units of grade 11 also will be solved. Thank you for watching.